Hello, everyone. Let's get started. Please download Laboratory 22 and population CSV file, this one, and Laboratory 22 from Blackboard. And please make sure to put them in the same folder, okay? Yeah, so here we need to learn the hypothesis testing in today's class. So first, you need to run the first script to identify your host name, username, and current information. And the next one, you need to input your name, our number, title, and the date. Okay, so let's see some questions here. The first question is about a histogram figure. So here we see we learned the histograms, and in our plot we have the same width of each beam, right? But this one is a little bit different. So here you ask, here's a question. So it's about the income of 2016 $1 million and the percent per $1 million. Percent of here means, for example, from 10 to 15 is 5%. This is 3%, and from 15 to 25 is 4%, right? So here is the which beam has more people, 10 to 15 or 15 to 25. So it means how to rate the figure, right? So to answer the first question, we need to know how to define the percent, right? And how to define the density, right? Here is density count divided by total counts and multiply 1 divided by beam width. So then we need to know how many people here we answer. The beam 15 to 25 have larger area because the width is 10, it's 10, right? And the height is 4. So it's like a 40% compared to the area 10 to 15. It's only have 5 and 5, so it means only 25%. So the last one, so the second one has more people. It's about how to rate and how to understand the figure, right? What percent of incomes are in the 25 and the 85 beam, right? So next one, you need to compute the width. The width would be 85 minus 25 is 60, right? 60, and then the height is hard to decide, right? But here we know it is like 0.2, because here is a 1%, maybe only 1/5, so it's 0.2. So 60 0.2 is 25, it's 12%. If you draw a single bar over 10 to 25, how tall it would be. So in this one we need to the density first, and then divided by this width, right? So we need to add the area of 10 to 15 and the area 15 to 25. So it means 40 plus 25 is 65, and 65 divided by the width here, right? 25 minus 10 is 15. So 65 divided by 15, so it is 4.33. So the total would be 4.33. Would be here, right? Perhaps here. So it's about how to rate the histograms. It's a little bit different with what we draw in the previous labs, okay? All right, so any questions so far? Okay, next one is about the probability. Here we have we have 10 marbles, and then we draw 4 at random with replacement. So probability of all G and no G and at least 1 G. So because it is with replacement for all G, it means you draw the first one, the probability would be 4 divided by 10 is 0.4, right? And second one, because you have already replaced it So the probability is the same. So it is 4 divided by 10, 0.4, 0.4, 0.4, right? It is this one. And no G, it means you need to select from the last 6, right? So 6 divided by 10, 0.6. So for each time, the probability would be 0.6. So the result would be 0.6 multiplied 0.6, 0.6, 0.6. So it's a result, right? And at least 1G, means 1 minus probability no G, right? So that's why here we need to, actually we can just use this way, right? More easy to understand, right? So because at least 1G, it means the opposite situation is no G, right? At least 1G means has 1G, 2Gs, 3Gs, or 4Gs. So 4 situation is very hard to compute, but you can compute the opposite situation. It means no G, right? And then use 1 to minus it. Yeah, so it's a result. Okay, so, and actually, yeah, so today's exercise is related to this one, but here's something wrong. We have the theme marbles, right? Theme marbles, but we need to draw 3, not 4. And sorry. Okay, so we can use 4, but without the replacement. So you need to answer this question. So so it means it means the probability for each round, for each time is different, because if you have drawn G for the first time, then there are only 3 G's left. So the second time would be different. Okay. So for instance here, let me show you the example. Oh, sorry. Let me show you the example. Let me show for all G's. This one is for the first time, right? But second time would be only 3, and then none marbles left, right? And for the last one, 8. And the last one would be, and the print PRGs, right? So here is for the first time, for the probability of all G's, because it's a little bit different, right? Because here is a without. Then after the first time, so all the situations have been changed. So please make sure, be careful, because it is without replacement. So it's related to exercise 2, but it's different. Okay. All right. So any questions so far? All right. So next one, exercise 3. We need to download the population, right? First, and then here is contains total populations of each country in the world over time. So we can click it, have a look. So here, geo time population total. I think it's about, here's a country code, right? Country code, different countries and the different time and different population numbers. Create a data frame named BANPOP for Bangladesh dash by performing a conditional selection and using a geo column. After that, perform another conditional selection, such as the column time. The data frame contains years from 1970 through 2015. So here is a little bit different, because we need to do several conditional selections in this example. Store the data frame after the second conditional selection variable and print out the first 5 rows to the output conditional selection. So first of all, you need to import pandas, right? So it's always the first step. Import pandas, import other necessary packages, and then use the pandas.read.csv and population.csv, right? And after that, you need to do two conditional selections. The first one, you need to select the geo, you need to select a country, right? So the country in the first column geo. So here is the pop, because the pop is the a data frame, right? And the set pop geo is BJD. It means the you need to use this one to do the first selection, and the bind pop is for the first time conditional selection. Second time, you need to use here is greater than or equal to 1970, and here is and operator, right? So same, you can use and, you can also use this operator. Time is smaller than or equal to 2015, and after that you have the third data frame after two conditional selections and do the head. Okay. All right, so as you see here, the index number, this is the index number, right? Actually, in the pandas, in the labs about the pandas, we learned the conditional selection. We learned how to compute the, for instance, you can use this you can find the which row is the minimum number, which row is the maximum number, but we didn't do the conditional selections for 2 times. So here's a question, here's an example to show you how to do it several times and how to use this operator, right? Yeah, so it is about the exercise 3. So any questions so far? Okay, and the next one is about another exercise. It's about the hypothesis testing. So outliers stream continuous chemical reactor is simply every 30 minutes, and here component contribution over 1,000 batches distributed by the mean value 41.2 and standard deviation 0.9, and then we need 5 determinations or concentrations of a component A are made. If the mean value is greater than or equal to actions taken, what is the level of the significance associated with the test? So yeah, so we need to design an experiment first, right? So first of all, you need to compute, you need to generate a distribution, right? A normal distribution here, use a numpy dot random normal, and then here's the mean value, and the second one would be standard deviation, and then third one would be the times, right? So the over 1,000 batches. So it is the first element, the first argument would be the mean value, standard deviation, batches. Then it is the distribution, right? And after that, we use it compute. We generate histograms on the data list, right? So this is about this one, right? It's label y label. It's for the first one because it's only one experiment. So next one here, we need to use the 5 choice because here we need to do 5 determinations. So here, that's why we need to use the random outcomes 5, because we need to like do the, because actually we use the NumPy random choice for several times. We, in the previous labs, we use like from 0 to 100, we randomly select 5 numbers. We can use this function, right? And then in this one, this is a distribution of the component A, and then you set 5. It means you select from this distribution for 5 times. It's also randomly selected, right? And after that, you compute the mean value, because here is only a 5 element list, right? And calculate the mean values, and then compare it with the distributed mean values, right? So as you see here, it's very close. And then after that, you do it repetitions. You do at several times, right? So repetition would be 10,000 and outcomes. So you compute the mean values several times, right? So because here is only one time, the compute the mean value of experiment for one time, and here because we use a for loop and 10,000, then we can get outcomes. These outcomes is pinned for each mean value. So after this loop, outcome is a 10,000 element list, right? And after that, you can compute you can draw another distribution, draw another histograms about the outcomes. It is about experimental results, right? And the scatter plot, you can draw the scatter plot. Here is a histogram, but you can also have a scatter plot. Scatter plot means the this one is something you want to know, right? 42.3, and here this minus this negative 60 is not necessary. It's only want you to know where is this dot, right? It's scatter plot, but there's only one dot, only one data, one dot, right? You can also set as 0 or any other things, or 2000, I think. It doesn't matter. Sorry, I think I need to run all of them. Right. Then you see the dot would be here because the x-axis is 42.3 and the y-axis would be 2000, but it doesn't matter. So it only want to it's used to show where is the required number, right? This is the required number. So from here. And after that, you need to do the hypothesis testing, because for now you have your standard number, you have a experimental number, right? Hypothesis non-zero is outcome larger than 42.3, then divided by repetitions. So it means only these histograms, only this small this bin, so the number of this bin is out of this standard data, right? And divided by repetitions, p value is only 0.2. So the p value will be only 0.2%, right? And next one is about the state now and alternative hypothesis. Next one is about the now hypothesis is A is this one, and alternative hypothesis is A is not 41.2, right? So it's about the hypothesis testing. And the last one would be you need to know, because here you have the value here is small, is the only 0.2%, right? So the p-value is 0.223%, is less than 1%. So it's highly statistically significant. So we can take this hypothesis, right? So it is how to do the hypothesis testing. So let me repeat again. So first one, you need to use the NumPy random normal to generate a normal distribution, because now you have the mean value, you have the standard value, and the batches, right? Here is a normal distribution, and then you need to randomly select some numbers. Here is the 5 determinations, but in some other cases, perhaps you need to select 10, but it doesn't matter, and then do the mean value again, and then do the repetitions for 10,000 times, and get a list of the mean values of the experimental results, and use the experimental results to compute with the standard data, and get the hypothesis testing. And p-value would be these outcomes, so experimental results larger than standard data, and divided by the repetitions, the numbers. then p-values and compared with 1%. Okay, it's about the hypothesis. All right. So any questions so far? Okay, so last one is about the exercise. You need to finish it by yourself. You can compare it with exercise 2, but exercise 2 is with replacement, so all G, no G, and at least 1G. So this one is result replacement, so it's a little bit different. So you need to finish it by yourself. All right. Okay, so that's all I want to share today. If you don't have any other questions, please feel free to leave the meeting. Thank you, guys. Have a nice day. And if you have questions, you can stay here and discuss with me. Thank you, guys. Solutions for access. No. You don't need to do the solutions. Actually, because I have already shown it for you. Solution for you for 1, solution for 2, for 3. So you don't need to do anything for the exercise 4. Only finish exercise 5. All right. Okay. So thank you. Okay, I will stop here. Thank you, guys.